start which ones do not work. So the ones that that are not equivalent are C and G. And that's it. So hopefully the first two you saw were P. If a radius is 5 rotated to 2 pi over 3, that is the same as 120 degrees. So you rotate theta, and then you count out 1, 2, 3, 4, 5 radians. So this is P, and this is point P. On C, I already crossed it out, but I want you to know why it's not true. Pi over 3 is over here, 60 degrees. A negative radius means I'd be in the negative direction, so that would be a point over here, which we could call point C, okay? Not the same as point P. D is at negative 5, 300 degrees. Well, here's 300 degrees, okay? Sorry, 300 right here. If I count 5 in the negative direction, I'm going to end up at P. Negative 4 pi over 3. Well, negative 4 pi over 3 is rotating pi over 3, or rotating 240 degrees in the negative direction. So take me down this way, and I will end up in the second quadrant. It's a positive 5 radius, so that's also at point P. Now, F and G are actually rectangular coordinates. There's no pi, there's no degree. This is X and a Y. So if I calculate the X and Y components of point P, X is going to be equal to the radius times the cosine of 120 degrees, or 2 pi over 3. And Y is going to be 5 times the sine at 2 pi over 3. Well, the cosine at 2 pi over 3 is 1/2, so I have 5 to 1/2, which is 5/2. And then the sine at 2 pi over 3, I'm sorry, that should be negative. It's negative in the second quadrant. The sine is positive, which is root 3 over 2, so I get 5 root 3 over 2. It's positive, which makes F the same as point P. Well, if F is the rectangular coordinates, that means G can be the rectangular coordinate. And then the last one we're going to look at is H. H is actually more than one lap around the unit circle. If I take 8 pi over 3 and I split it up into 6 pi over 3, that's 2 pi, plus 2 pi over 3. Total, this adds up to 8. So this is one lap around the unit circle. And then 2 pi over 3 more lands me at P. The last thing you have to do is on the back, and we've done this so many times, looking at the tangent quotient. If you take sine over cosine, there are only so many tangent values you can get using the unit circle. Okay, so I know if my tangent is equal to 0, then I had to be at either the pi, 0 pi's, or at pi, or 2 pi, or 3 pi. If I'm dividing 1/2 by the square root of 3 over 2, this is going to simplify into root 3 over 3. Now this is going to happen when sine is 1/2 and cosine is root 3 over 2. So that's going to be at any of the pi over 6 values. Now obviously we could plus or the minus signs here, positive or negative, you're going to get these ratios. Now at root 2 over 2 divided by root 2 over 2, that's going to equal 1, and that will happen at any of the pi over 4 values. You'll get a tangent equal to 1. And then sine is root 3 over 2, cosine is 1/2. That divides to equal root 3. So if tangent is equal to root 3, you're at a pi over 3 value. And then if tangent's undefined, 1 divided by 0, then you have to be at either pi over 2 or 3 pi over 2. We're going to be using these a lot because remember with polars, we do not get our calculus. All right, next you're going to get a worksheet to work on with your groups. The front is just an overview of your notes. You're going to want to get a book and go to the pages I've listed here. You work on matching these graphs to the function. So using the diagram on the front will help you do this, okay? If you need more help, then you need to go to your book, okay? You need to turn to the pages in your book in order to do that. Hold on, let me get the page number. Has it, the hole puncher kind of cut it off. So it's page 750 to 72. All right, good luck, and I'll see you next week.